Welcome back to the channel, everyone. In this video, I'm going to explain the questions found within the 2022 May Physics High Level Paper 1 from Time Zone 2. Because of copyright reasons, I don't think I can show the actual paper. Nevertheless, I have paraphrased and summarized most of the relevant information from the questions on this Google document, and I hope this will be sufficient in explaining the reasoning behind the correct answer to each question. I also hope that you guys can get a hand on the paper from either your teacher or from other legitimate internet sources. So let's get started with the first question, which is about uncertainty propagation as the area of a circle whose radius is 10.0 plus or minus 0.5 is being asked for. The area itself is straightforward. Area equals to pi r squared. 100 pi, this is going to be 314. 10.0 is a 3 sig fig figure, which means that the final answer should also be reported to 3 sig fig. The other part of the question is for working out the uncertainty of the area. In this case, what you have to do is to refer to uncertainty propagation rules, which says that whenever you power a number with uncertainty, what you have to do is to multiply the fractional uncertainty by the power. In this case, the power is 2, and the fractional uncertainty is 0.5 divided by 10, and this amounts to 5%. Squaring involves the doubling of the fractional or percentage uncertainty, which can then be multiplied by the mean figure, which is the 314. And then rounding the uncertainty to the same decimal place precision as the area itself allows you to conclude that the best way to report the area is 314 plus or minus 31 cm squared. So choice D being the correct answer. Now, question 2. Two different experiments, P and Q, generate two sets of data to confirm the proportional relationship between two variables, X and Y. And the four choices involve identifying the graph that, number 1, shows less systematic error or more systematic error. And then secondly, which graph shows a smaller uncertainty of the gradient. Well, first of all, systematic error has to do with how far the line, how much the straight best fit lines deviate from the origin. And we refer to the origin because the two quantities are known to be proportional to each other. Quantities that are proportional to each other should have a best fit line that is directed at the x-axis. So graph Q actually shows no systematic error, whereas graph P shows that there is a systematic error either in the y direction like this, or in the x direction like this. In any event, the systematic error is larger for set P. Meanwhile, the uncertainty of the gradient, I think it is quite apparent that the uncertainty of the gradient is much larger for graph Q rather than graph P, as evidenced by the smaller angle made between the two best fit lines for graph P relative to graph Q. Overall, the answer is C. Moving on to question 3. An object slides down a frictionless inclined plane, sliding 1 meter during the first second. And the question asks what distance will the object slide during the next second. So this is a ratio opportunity. And first of all, opportunity to apply the Suvite equations, and secondly, you can use ratios. It's quite similar to this type of situation. So using the same Suvite equation twice. So which Suvite equation should we be using in this case? Well, we know that the objects start from being at rest, and the question relates time and distance, which means we can use this s equals half at squared twice, as nu over s equals to half a down a frictionless inclined plane. Even if the inclined plane has friction, as long as the angle and the roughness remains constant, then the a will also be constant. We can actually try to figure out the a, but then that's not really needed. halves are gone, eighths are gone. During the next second means that because first figure out the total distance split over the entire 2-second duration. So S2 over S1 would equal to just 2 square over 1 square, which equals to 4 to 1. So by the end of the second, the object would have split a total of 4 meters, which means that during the second, the object would have split 4 minus 1, which is, well, 3 meters, which makes the answer C. Question 4 now, a ball is thrown upwards at time t equal to 0, and the graph shows a parabola, and they ask you for an equation, they ask you for a relation that relates height with time. If you know your math, then I trust that you immediately recognize that only choice A and D correspond to a parabola in small t. And by the way, I probably should have labeled this x-axis better. The capital T is actually a constant, and small t is just a time in general. A sad face parabola basically forces choice D to be the correct answer, because if you expand this, you can see a negative t squared term, which corresponds to a sad face parabola. So if you know your math, then the correct answer should be super clear. If you don't know your math, however, then how is it possible to figure this out from scratch? Well, the total hang time of capital T means that the time taken to the top is T over 2, and then what you can do is to use a Surfeit equation. You can use V equal to U plus AT to figure out the starting speed. And the figuring out the starting speed is useful because the height-time relationship is basically, because height is basically just S within S equal to UT plus half AT squared. But to complete this relationship, we first need an expression of U in terms of some of the quantities given within the question. So we know from V equal to U plus AT, 0, which is the speed at which the object reaches the topmost point, equals to the starting upward speed, I can say velocity, I guess, minus G. And then the time taken to reach the top is capital T over 2. Therefore, G capital T over 2 is U, which you can now use as the U for the second Surfeit equation. So height equals to G capital T over 2, small t plus half. Actually, it's going to be minus, because G is downwards. I'll just write plus half and then negative G and then small t squared. And if you factorize, I feel that you just get G small t over 2 bracket T minus capital T minus small t, which is choice D as well. So definitely a method that works, but if you know your math, then you can get there less clumsily. But let's move on for now to question 5. So solid metal ball is dropped from a tower, and then they give you a velocity time graph that clearly shows that acceleration is not constant, which means that friction is not negligible. And then they say that the experiment is repeated when they drop a metal ball that's same size, same shape, but hollow in the inside. Fortunately, they don't have a graph that looks exactly the same as the original graph. And with a hollow metal ball, I think students can infer that the acceleration must be less over time as the effects of air resistance becomes more significant. So the choices A and B, which involves a faster acceleration, a higher average acceleration, is definitely wrong. So it boils down to choices C versus D. So graph C has a very similar initial gradient as the original graph, whereas graph D has a lower original gradient already. So a different original gradient corresponds to a different original acceleration. And I believe choice C is better because at the beginning, when the object is at rest or when the object is low, the air resistance is not really that significant. And the acceleration, which is the gradient of the velocity time graph, should be the same as that for the solid metal ball, at least near the beginning of the fall. And sure enough, choice C is the correct answer. Question 6 is about identifying Newton's third pair forces. So there's an upward propulsion force due to the rocket. And F2, meanwhile, is the weight of the rocket. And the question asks you for the corresponding Newton's third law pair. So F1 is thrust by gas on rocket. And it would just stick to the Newton's third law definition. The reaction pair would be the force on the gas by the rocket. Making choice A and B correct for now. The force with pair F2, which is the weight on rocket due to Earth, and the corresponding third law pair would just be the weight on the Earth due to the gravity generated by the rocket. And that sounds pretty weird, but that's how third law works. Like everyday objects generate like negligible gravity, but very small gravity acting on a huge mass like such as the Earth can also cause the Earth to experience an equal and opposite reaction force, which is weight in this case. So answer is B. Now, question 7 is a difficult connected object question. The system is accelerated by someone pushing a table with wheels, and then on the table there's a book, and of course there is friction between the table and the book. And the question asks you for the maximum acceleration that the book can sustain without slipping off the table. The final answer, I'm going to give you the full analysis of the forces acting on the system, even though the final answer does not require that much. What you can do, write two equations of forces on the table with wheels. You have a push force acting forward, and you should have some backward acting friction, which is mu small mg, because that's the reaction force between the two interfaces. That would equal to capital MA. Meanwhile, for the book, you actually have some Newton's third law equal and opposite friction, which is also mu mg. Mu mg equal to small ma. And if you cancel the small m's within the second equation, then you can see that the acceleration just simply equal to mu g, and that's choice B. There could be a question which asks you for the maximum possible push so that it can push the book and the table together without the book slipping. If that's the case, then you have to use this acceleration, A equals to mu g, substitute this into here, and then most likely you'll have to rearrange for P. So, but in general, what I would do for these kind of problems is to actually write out both equations of forces, like how Newton's second law applies to perhaps the entire system as well as the individual objects, in order for you to have more information to work with. So let's move on. Question 8. Two identical springs with springs constant given, and then they give you identical compressions. They give you both masses, so it's kind of a weird question because they just give you a lot of information. But at the same time, you can just use the same equation twice to calculate the release velocities. The equation required for calculating release velocities, however, still involves people recognizing the need to equate the spring energy, which is half kx squared, with half mv squared, because these situations where the compressed springs would transfer all the elastic potential energy into the attached object, allowing the object to carry the energy in the form of kinetic energy. If you just plug numbers into the equations, you're looking at half kx squared, so half 100. I think you do need to crunch the numbers. The compression is 0.1, where equal to half. The first mass has a mass of 1. If we cancel the halves, the left-hand side, this is 100 times 0.01 is exactly 1. Therefore, Vx just equals to 1. So choices A and C for now. For block B, you can do the calculation, but if with block B being less massive, you would naturally expect block B to go block Y, I should say, to go faster. And sure enough, if you replace the 1 from here with 0.25, which is the mass of block Y, the corresponding Vy will indeed be 2, which is what choice C presents. Therefore, the answer is C. Moving on to question 9, and we are now into ideal gas. What is true for an ideal gas? And they give you 4 equations, only one of which is true. Turns out the correct answer is A, and the way to figure this out is to just recognize, well, typically you recognize PV equal to nRT. And number of moles, meanwhile, can be written as number of particles, which is what capital N represents, divided by Avogadro's constant. And then ideal gas constant itself is actually Boltzmann constant times Avogadro's constant. And then you can see that the Avogadro constant cancel, and that's how you can show that small n times capital R is equivalent to capital N times Boltzmann constant. These are not directly given in the formula book, but I'll show you my take on this situation. It should be apparent. Like, in fact, they actually tell you that KB equals to ideal. From this equation that's given in the formula book, you can see that the Boltzmann constant actually equal to ideal gas constant divided by Avogadro's constant. I use L because L is the notation that's commonly sometimes used in the chemistry paper. Meanwhile, what I also showed earlier on, number of moles small n equals to capital N, which is number of particles divided by Avogadro constant, is some basic knowledge that you guys should know. In any event, the answer should just be A. Now moving on to question 10, which assumption is part of the molecular kinetic model of ideal gases? The first choice says work done equals to the change in kinetic energy of the system. This statement itself can be true in some cases, but it's definitely not part of the molecular kinetic model. This statement can be true if you guys study thermodynamics under option B, then there will be some situations where work done on a gas corresponds to the change in the kinetic energy of the molecules of the gas. Secondly, the volume of a gas results from adding the volume of a gas results from adding the volume of the individual molecules. Is just entirely wrong. For kinetic model of ideal gases, the volume of a gas is defined by the volume of the container, while the volume of the molecules themselves are negligible. So the molecules are point masses with no dimension, so zero volume. But choice C actually is the correct one. A gas is made of tiny identical particles in constant random motion. That's perfectly correct. And then part D, all particles in a gas have kinetic and potential energy, and that's half wrong because under the ideal gas model, the ideal gas molecules experience no intermolecular forces unless they are colliding. And having no intermolecular forces correspond to having zero PE. Overall, choice C is correct for question 10. Question 11, water at room temperature is placed in a freezer, and they ask you for the correct cooling curve. So cooling the water and then freezing the water, and then further cool the frozen ice. And the 4 graphs given have different gradients for the cooling of the water versus the cooling of the ice. And what you guys are meant to recognize is that the smaller the specific capacity, the steeper the cooling curve. And the mathematics is actually fairly straightforward. By rearranging PT, P for power, and T for time, so PT represents the energy given or energy extracted from the system. By rearranging PT equal to MC delta T, you can see that the gradient of each heating or cooling curve is inversely proportional to the specific heat capacity of the substance. So ice, which has a lower specific heat capacity, should have a steeper cooling curve, like more rapid rate of cooling. So the correct answer should be a graph that looks like this. Cooling of water is less rapid than cooling of ice. And choice B would be the correct answer. Question 12. What quantities of a simple harmonic oscillator can be simultaneously zero? A fairly straightforward question about SHM. And if you're familiar with this kind of situation, you can easily recognize that at certain stages of oscillation, the object, especially at the equilibrium position, the displacement is zero and then acceleration is also zero because acceleration is proportional in value to the displacement of the particle at all times. So the answer would be choice B, which says displacement and acceleration. And you can also relate, you can also use this equation, A equals to negative omega squared x. Recognize that omega is a constant. When x equals to 0, A also equal to 0. Moving on to question 13 now. Given two sinusoidal displacement time and displacement distance graphs, first of all, the word displacement refers to the displacement of a particle that is oscillating within the medium, whereas the word distance refers to how far a location is from the source of the wave. So the quantities provided by the distance time graph, I should say the displacement time graph, is actually period. So PQ is actually the period, whereas RS is actually representing the wavelength. Speed of the wave is given by, everyone knows speed equals the frequency time wavelength, but the derivation of this equation is actually based on the fact that frequency is 1 over period, and then a wave will travel one wavelength within one period. Therefore, the speed of the wave is RS divided by PQ, which is choice C. And just to show this information, so displacement distance graph is a snapshot of a wave and shows the wavelength and amplitude as well. Whereas the displacement time graph tracks the vibrational motion of a particular point somewhere on the wave, and then you can tell the period of oscillation from this kind of summary graph. Anyways, let's move on to question 14, which is about refractive index of glass and water both given, and they ask you for the critical angle for light traveling from glass to water. You can definitely use an equation, but the problem is that there's some rearrangement. What you have to do is to recognize you need to use this n1 over n2 equal to sine angle 1 over sine angle 2. And you further need to recognize that when light travels from the dense medium to the less dense medium, so glass is more dense optically than water. And use n glass and water equals to angle water, angle glass. And further recognizing the angle in the less dense medium is going to be 90 degrees if we are at the critical angle. And then sine 90 is 1. So we're looking at 3 over 2 over 4 over 3 equals to 1 over the critical angle of glass. And if you rearrange the left-hand side, I think you can see that the left-hand side fraction would amounts to 9 over 8. And the only choice that has a 9 and an 8 is choice D. Well, actually, my bad, I left out the sign for some reason. The sign should be there. Cross multiply, sine of the angle of incident within the glass is 8 over 9. So inverse sine to get D as the correct answer. Moving on to question 15. Unpolarized light of intensity 320 watts per meter squared goes through a polarizer and an analyzer, originally aligned parallel. And the question is asking for the intensity of the light emerging from the analyzer. The proper way to calculate the transmitted intensity in this kind of situation when you begin with unpolarized light, what happens first is that the first polarizer will always halve the incoming intensity regardless of polarization. And then for the second polarizer, you can then use Malus's law to determine the transmitted intensity. So for this particular question, the 320, after going through the first polarizer, we'll see its intensity halved, so becoming 160. And then you can use Malus's law to calculate the intensity after traveling through the analyzer, which is basically a second polarizer. So cos 30 is given to be root 3/2, but I hope you guys know your math well, because you definitely need to know this for most math courses. Root 3/2 is cos 30, and if you square this, 160 times 3/4, that's 120, making choice A the correct answer. Okay, moving on to question 16. They give you a configuration of 4-point charges, but I think the correct answer is very straightforward. You have vertical symmetry regarding what the positive and the negative charges will each do to that particular position. And meanwhile, the electric field due to the positive charges should be acting like this. For the two positive charges, generating a field at that point which points away from the positive charges themselves, while the negative charges will apply an inward pull towards a positive test charge position at that top location. And you can see that all 4 electric fields have a component that acts towards the left-hand side, and that's definitely not going to be cancelled. Therefore, choice D is the correct answer. Moving on to question 17, they give you an original circuit with a simple battery and a lamp, no internal resistance, and then adding a second identical lamp in series. So the question asks for what happens to the battery output. What happens to the PD to the original lamp actually first? So in converting a simple circuit into a simple series circuit, in series, the two bulbs would have to not share what used to be still the same source voltage, the same EMF. Identical bulbs would just have to share the source voltage. So the source voltage, the potential difference will definitely decrease. It will in fact, you can further say that the potential difference will halve. Meanwhile, the output power of the battery is best calculated. Well, there are quite a few equations. P equals to IB. You can use P equals to IB on the second circuit, realizing that doubling the number of bulbs corresponds to the doubling of resistance, which corresponds to halving of the current. Halving of the current without changing the EMF means the power will be halved. Therefore, the output power of the battery will decrease. There are other choices that you can use. You can use P equal to I square R. You double the resistance, but then you halve the current. And since the current is squared, power will also halve. And if you use P equal to V squared over R, that can also work because V is the EMF which remains constant. But then having 2 bulbs means that the resistance has doubled. Accordingly, power will be halved. In all cases clearly show that the answer is choice A. Moving on to a funny looking circuit. They ask you for the reading of the voltmeter, which is connected in a bridging way. What you can do first is to analyze the potential at these 2 different locations. And to analyze the potential, what you can do is to first analyze the potential difference across the left branch and the right branch separately. This is the overall parallel circuit with series resistor within the left branch and the right branch respectively. The 3 volt will be shared by the 1 ohm and 2 ohm resistor in 1:2 ratio. So the math is quite simple. The top left resistor dissipates 1 volt. The bottom left resistor dissipates 2 volts. But if we consider the potential instead of potential difference, we can see that the wires highlighted in pink here, they are all experiencing, or they are all at so-called 3 volts. And then after the top left resistor uses up 1 volt, there are 2 volts remaining at these locations. And then the black branch has 0 volts. And if we apply a similar analysis on the right branch, the top right resistor experiences 2 volts, which means that the right junction would be at only 1 volt. And you can see that the voltmeter is connected to 2 points, which have a potential of 2 volts and 1 volt respectively. Hence, the potential difference is just 2 minus 1, which is 1. And this is definitely not a trivial circuit. And they can give you, I think they actually had a more complicated circuit in the other paper. Also on like working with potential instead of potential difference. So this is definitely a technique that you guys can study, and I'll just clear my drawing first and let you guys read a little bit. Moving on to the next question, a motor diagram. A motor has pretty much never appeared in the IB paper, especially since there is rotational motion. People who study IGCSE will probably know this well. O-level as well, I'm guessing, because the motor is part of the IGCSE syllabus. And most students would be familiar with this thing. Like, at least most students from IGCSE should be familiar with this thing. This is called a split ring commutator, and the semicircular parts will actually rotate along with the coil. The left terminal and the right terminal are maintained at, say, positive and negative, perhaps. And what happens is that the current is fed into the coil like this. It will return, and then after the coil has undergone some rotation, maybe half a rotation, the semicircular parts called the split ring commutator will make contact with the opposite terminal. The current direction will reverse, but then reversing the current direction can actually allow continuous rotation to occur according to Fleming's left-hand rule. But for this question, they want you to figure out the variation of force with time. So let's say the terminal is labeled positive and negative as such. So at the beginning, let's say the rotation is clockwise as shown in the actual diagram. Applying the left-hand rule on section XY can help you reveal that the direction, well, the force is either going to be straight up or straight down. It doesn't actually matter. But if you just use FBI, I think the force is going to be, just B is my index finger, and it's from right to left. And then the current, which is my middle finger, is pointing into the page or into the camera. As a result, XY experiences an upward force according to my polarity destination. And this upward force will result in different rotational motion, but then there is a torque that decreases as the ring adapts a more vertical position. The question, however, is asking for the force and not the torque. And torque, which is turning motion, is not within the core syllabus anyways. So as long as the current is maintained in the same direction, the force will also stay in the same direction. And then after half a rotation, when the coil becomes vertical, there should be no more. The force will, this is more like the position where the force will change direction, because once the coil swings to the right-hand side of the diagram, the current on the right-hand side will result in the force acting, well, the coil swung to the right side will result in the current reversing direction, because this semicircular ring will be making contact with the negative terminal instead. So for this these stages of the rotation, which is the second quarter and the third quarter of the rotation, the force the reverse direction. And then the last quarter of the rotation, the coil makes its way back to the left-hand side, making contact with the positive terminal. The force therefore would resume would return to the positive direction. Therefore, choice A is the answer. First, D would be the answer if we are talking about the torque or like the turning effect, and that was actually what I chose when I first attempted the question myself. So that was the only wrong one that I had. So, but hopefully the explanation is clear, like regarding the function of the so-called split ring commutator. This guy here. So question 20. Now, statement about an orbiting satellite. So a satellite is orbiting Earth in a circular path at constant speed, and then there are 3 statements regarding the resultant force, and the question wants you to pick out the correct statements. So the resultant force equal to the gravitational force of attraction on the satellite. And turns out that's correct. In order for an object to undergo circular motion, there needs to be a force that's always directed towards the center of rotation. In the second statement, the resultant force equals to mass of the satellite times acceleration of the satellite, and that's definitely correct because that's a simple application of F equals to ma. The third statement says that the resultant force is the centripetal force acting on the satellite. Definitely true as well, because the satellite is orbiting at constant speed, meaning that there's no tangential acceleration. The only acceleration that the satellite is experiencing is centripetal in nature. So centripetal force provides centripetal acceleration. So all 3 statements are correct. Moving on, question 1. An astronaut is orbiting Earth in a spaceship. Why does the astronaut experience weightlessness? Well, first of all, weightlessness does not mean that the person or the object experiences 0 gravitational force. Rather, weightlessness is actually just a sensation. And the reason that the object or the person will not be able to feel its own weight is because the object or the person is experiencing the same acceleration as gravitational acceleration. The explanation is here. So in a situation where the object experiences the same acceleration as gravitational field strength, the object is weightless because there will be no reaction force even if you try to place a supporting surface underneath the object or the person. So the person is not truly weightless. It's just that the person would not be able to feel its weight. And the answer to this question is choice B, which says that the acceleration of the astronaut is the same as the acceleration of the spaceship. Okay, moving on to question 22, which asks for the nature of a spectrum. So when white light is emitted from a hot filament and the white light is passed through a sample of hydrogen gas at low pressure and then through a diffraction grating, they give you a spectrum, then they ask you whether the lines are dark or bright, and they also ask you for the background. Is the background black or white? Or more like is the background black or colored? Well, first of all, the question is describing an absorption spectrum. I don't remember an absorption spectrum being tested in before, but here I'm going to show you the notes. I don't actually have the absorption spectrum, sadly. But what happens is that you shine continuous light on a sample that's capable of absorption. And what happens is that the transmitted light, which is the remaining light is remaining continuous light, which is incident on an optical device, such as a grating, will show mostly the continuous spectrum with dark lines that are due to the absorption of the gaseous species at specific frequency or wavelengths. So for this question, the lines will be the dark ones and the background will be bright. And that corresponds to choice D being the correct answer. Question 23 now, 3 statements about electrons, so particle physics. So electrons can interact through virtual photons or gluons or W and Z particles, but turns out the middle choice is wrong, because gluons are the exchange particles that mediate strong forces. Electrons are leptons and cannot experience a strong force. So if the second choice is wrong, then that means that the first and third choices must be correct by default. And sure enough, they are correct. So the answer is just 1 and 3, which is choice B. Moving on, question 24. which describes a nuclear reaction during which a neutron is absorbed by a nucleus of uranium-235 to become two daughter nuclei with identity fully shown. The question asks you how many neutrons are released, and what a lot of people will overlook is the fact that there is a hit to neutron. So there's a total of 236 nucleons involved. And in a nuclear decay, in a fission reaction, the total number of nucleons don't actually change. All the nucleons should still be accounted for, and you can see that there should be a total of 233. Which means that there must be 3 nucleons, so the 3 neutrons which are unaccounted for at this stage. Therefore, the correct answer is 3 neutrons, D. Now, question 25, a radioactive nuclei decays into a different nuclei, and the question says that the 2 nuclei have the same nuclear number. So 2 parts of the question, you have to first distinguish whether this is an alpha or beta decay. Hopefully, it's super obvious that this is a beta decay because during an alpha decay, there is a decrease in nucleon number by 4 as a collection of 2 protons and 2 neutrons are emitted. That's what we call the alpha particle. The half-life for this question is also fairly easily figured out because all you need to do is to look at the y-axis with initial activity, and you need to find the time when activity is halved. So clearly the half-life is going to be 2t. And the answer is choice D. Question 26. Distinguish between how energy is converted by photovoltaic cells and solar heating panels. I think the names are already quite self-explanatory. So photoelectric cells generate electrical energy from solar energy, whereas solar heating panels generating heating effect, which is clearly thermal energy. And choice A would be the answer. Question 27. 3 statements about fossil fuels are: number 1, there's a finite amount of fossil fuel on Earth. Secondly, burning fossil fuel releases CO2. And thirdly, there's uneven geographical distribution of fossil fuel natural resources. And the question further asks which statements justify the development of alternate energy sources. I think the first and second statements are both very clear. Okay, if the fossil fuels have a chance to run out, then we have to find other ways to harness energy. Carbon dioxide, meanwhile, as a greenhouse gas, is definitely believed to be the culprit of global warming, which can cause climate change and damage to the Earth in the long run. And then lastly, geographical distribution of fossil fuels is uneven. It had led to economic inequality, so definitely a good way for countries to find other ways to help sustain their own economy. Maybe not try to invade other countries in exchange for freedom, maybe. In any event, the answer should be all 3. Moving on, question 28 is a very weird question. The age of the Earth is given to be blah, 4.5 times 10 to the 9 years, and then which area of physics is the area that provides experimental evidence for the age of the Earth? But first of all, you guys need to recognize that Newtonian mechanics have nothing to do with the age of the Earth, and neither does optics. Radioactivity, however, by determining the abundance and also the activity of radioisotopes on Earth, we can figure out, we can use the half-life of certain isotopes as an estimate of the age of the Earth. Like when Big Bang happened as well, so you can actually use to detect to figure out the age of the universe as well, I think. But in any event, electromagnetism, not quite. Okay, it's radioactivity half-life determination that is linked to some determination of really long time, like timestamps. Moving on, question 29. A simple pendulum has a period t, and then the pendulum period is remeasured when it is flown to the moon with less gravity. So the new period can be calculated by using this equation, which is provided in the formula book. Temperature, no, not temperature, period equal to 2 pi L over G, where L is the length of the pendulum and G is gravity, or square rooted. So if G becomes 1 over 6G, I can stick to the ratio approach that I used in some other previous questions, but I think for this question, it's quite obvious that the pendulum will have a longer period, and then the duration of the period should be, wait, did I, no, yeah, longer period again. Choice A, the answer. If you have T new would equal to T old times 1 over 6, and this is root 6 times T old, which is what choice A is. Moving on to question 30. So in two different experiments where white light is passed through, firstly a prism and then secondly a diffraction grating, and they asked you which beams are red and which beams are violet. The grating experiment, the result is quite famous. You have to recognize that red has long wavelength and would undergo more diffraction and having a wider angular separation from the central maximum, as evidenced by an equation like this. Long wavelength, large angle, so therefore P is definitely the red one. The prism one, however, is, I don't think it's clearly stated that within the visible light spectrum, red is the one that refracts less. I guess this is the first, but hopefully you guys have done enough fundamental physics in earlier years to recognize that red refracts more. So red refracts less, but diffracts more compared to purple. Especially for the prism case, because there is no simple mathematical relationship that relates wavelength and refractive index. So question 31, a train sounds a whistle when it approaches a station, and the question has 3 statements which you have to determine are they correct or not. So a train sounds a whistle when it approaches a station is a situation where you have an approaching source that's emitting sound. In this kind of situation, what happens is that the frequency increases, and that in turn is because wavelength decreases while the speed of the wave remains constant. So the answer is 1 and 3, because the change of wavelength proposed by the second point, wavelength received is longer, is just not true. And I have a Desmos demo that I can show. So the object is moving. The purple dot represents the object. And you guys can see that the wavefronts once emitted will just travel at the same speed. So the leading front sees the wavelength compressed. And at the receiver, which is the red dot, experiencing shorter wavelength waves approaching at the same speed, the mathematics will just force the frequency to be higher than the original frequency. Okay, moving on to question 32. So a configuration of 4 point charges, and they're asking for the potential as for the field and then the potential at the center of the square. For determining field, you have to consider direction for sure, but the symmetry of the situation clearly shows that the field due to the positive charges will cancel. The field due to the negative charge would also cancel. Therefore, electric field equal to 0. Electric potential, however, the treatment is different. Well, first of all, there's a different equation. And secondly, the potential should just be added mathematically regardless of direction. Well, potential is a scalar, has no direction. But because of the symmetry of the charges, well, the distance is the same. You look at KQ over R, 2 of them, and then you've got 2 negative potentials due to the negative charges. So the total potential also equal to 0. So the geometry is kind of straightforward, I think. But there have been nastier questions in the past. So this one, however, it's clear that both the field and potential are 0. Question 33 now, they give you a electric potential, how the electric potential varies at different distances from a charge, and they ask you for the meaning of, they ask you for a certain property of the graph that corresponds to the electric field strength. For this, I think you guys just need to recognize the relationship between potential and field. So electric potential gradient refers to change in electric potential across two different positions within a field. And if you have a electric potential gradient, if you have an electric potential graph, the gradient of this graph over distance actually corresponds to the negative of the field strength. And this is also true for gravitation. So the answer here is just going to be choice D. And you can recognize that it's a negative because, well, first of all, the formula will actually give you this equation. And secondly, if you have positive potential, that means that you have a positive point charge located at location 0, and the decreasing potential actually corresponds to, well, a negative potential gradient. That decreasing potential means negative potential gradient, and that also corresponds to an outward field, and an outward field corresponds to a positive sign. And this is how you can recognize that you need to take the negative of the gradient of the tangent to correspond to the electric field strength. Moving on to question 30. Which two features are necessary for the operation of a transformer? So for a transformer to work, the question asks you for the nature of the connection between the primary and secondary coils. And the question also asks for whether you need alternating current or whether you need direct current. The answer should actually be super straightforward. As long as you remember the construction of a transformer, so there's an iron core with coils wrapped around. The iron core, however, is not meant to conduct electricity. The iron core is just meant to allow the magnetic field to channel from one coil to the other coil nicely. Therefore, first of all, magnetic interaction has to be, well, the connection between the coil has to be magnetic, while the current needs to be alternating. If we use direct current will stabilize. And with the current being stable, there's no way that you can generate a changing flux, which is otherwise required to induce an EMF in the secondary coil. Again, alternating current generates alternating magnetic field, which can be felt by the secondary coil. And then according to Faraday's law of electromagnetic induction, it's the alternating flux that is capable of inducing a secondary voltage. So for this question, the answer is choice B. Question 35 now. So there is a metallic conductor falling in the presence of a magnetic field, which is directly into the page. And the question asks you for the side of the bar that has that is got the greatest density of electrons, which are of course negative. For this kind of situation, what I suggest you guys to use is the left-hand rule. A lot of teachers try to encourage the use of the right-hand rule, but after doing past papers, I think you guys will agree that the right-hand rule is actually not that good. But what you can do is to treat the direction of motion of the conductor as I, so the conductor is falling. So you can treat that as I, because by treating this as I, you can record the force acting on the mobile charged particles internally within the rod, and that allows you to determine which way the positive particles actually move. So applying the left-hand rule with current, which is actually the direction of fall of the bar, downwards, in the presence of a magnetic field acting inwards, shows that the positive particles are going to migrate towards QS. Actually, QR, I think I labeled the diagram wrong. This is R. This is S. So the positive charge migrates over here, which means that the electron which are negative will be migrating towards PS. Therefore, choice D is the answer. Question 36 is a capacitor circuit, and they ask you how much charge will be stored in capacitor Z and as well as capacitor X. So for this question, what you can do is to first figure out the individual capacitances. Well, they're all C, so the capacitance of the system, X and Y are in parallel, so the effective capacitance is just a simple sum, whereas Z is in parallel in series with the parallel system, and we will have to use the reciprocal formula. And you guys can work it out. It's actually 2/3. See, is this actually useful? You guys may wonder. Well, it turns out you can use Q equals to CV to figure out how much charge will accumulate at like certain locations. So if this is the C system, then the Q that you are calculating is actually going to be here as well as here. So Q equals to, so for C system is 2/3 CV, and that should also be QZ. And then the charge meanwhile will be distributed across the two plates X and Y according to their capacitances. Well, because they have the same capacitance, you would therefore expect them to share the charge equally. Therefore, the answer is C. Question 37, 3 correct statements about the behavior of electrons are given, and then which statements are explained using the wavelength property of electrons. Well, electron beam used to investigate structure of crystals, yes, for sure, because we rely on electrons to diffract through the gaps, the spacing within the crystals. The second one, electron beam produces fringe patterns. Well, fringe patterns are also the result of the diffraction, so therefore the second one is correct. Whereas the last one, electromagnetic radiation ejects electrons from the surface of metals, is actually an experiment that supports the fact that light has particle behavior, which is it's basically the opposite of electrons, which are well known to be particles at the time of discovery, have wave-like behavior. The answer for question 37, therefore, is just A. Now, question 38 is a complicated ratio problems. Two samples. Sample Y is half as abundant as X in terms of the number of radioactive particles. The half-life for the sample X is, well, sample Y is twice as long, so it's less reactive. And then the question asks for the initial activity. And there is an equation that goes like this. Activity equals to lambda times n. And lambda in turn equals to half-life. Actually, my bad, ln2 divided by half-life. And these equations were given in the old formula book. Not anymore, I believe. I think it's given in a more implied way, which I'll show you now. So activity rather, equal to lambda n can be inferred from the topic 12 equation. And yes, we are definitely doing topic 12. So basically comparing this to this, we can see the initial activity equal to lambda, which is decay constant, times the number of radioactive particles within the sample. And then the half-life equation is also not given. So something that you guys definitely need to know well. So now knowing these equations, we can apply ratios to figure out AX over AY. And the bracket is going to be as such: AX over AY equals to ln2 over T half X times NX ln2 T half Y times NY. And if we now replace some of we'll cross out the ln2s, NX meanwhile equals to 0.5 and Y, and then T half X is 2 T half y. You can further cancel the ny's like this, and then cancel the t half y's like this. So we are only left with 0.5 over 2 within the numerator, and that translates to 1 over 4, which corresponds to choice A being the correct answer. Now, question 39. They give you some kinetic energy related to frequency kind of graph, and that's actually a very typical graph under photoelectric effect. And what they're asking is, what happens when you repeat the experiment with a surface which requires less energy to remove an electron from? And this sentence basically refers to a method that has a smaller work function. Ke, meanwhile, equals to the incident light energy minus the work function. So if you plot a graph of Ke against that, the negative of the y-intercept is actually the work function. And using a method with a lower work function means that the graph should have the same gradient, because the gradient corresponds to the Planck's constant, which is, well, a constant. And the new y-intercept will be less negative. And according to the graphs given, only choice A makes sense. The last question: what is a possible probability density function for a given electron wave function? The y-axis is already squared, and anything that's squared is going to be guaranteed positive. Therefore, it's going to be not choice A and not choice B, because those choices have a negative section. So it's just illegal. Where choices C and D have this shape, and that's correct. What you have to do is to distinguish between distance versus time for the horizontal axis. These are probability distribution functions for locating an electron within the atom. The x-axis, therefore, is the distance from the nucleus. It's not time. Therefore, choice C is the correct answer. Well, this completes the analysis of the entire paper, and I hope everything has made sense. So good luck with your revision, and I'll see you guys probably in half a year. Thank you for watching.